Welcome, this is the cooking show. Hello, I'm your host Paul Carrasco. For those of you who don't know, this is the first and only cooking episode. So we'll start with something simple, brownies. To help us on this endeavor, we don't have one co-host, but three. So let's bring on Maddie. Round of applause.
Hello.
So how are you feeling today?
Good, and I'm glad to be here on the show.
So Maddie, let's get started. We have to melt the butter, don't we?
That's correct. And we shall also mix the butter with the rest of the remaining ingredients.
Well, that sounds good. And as I saw on your resume, you are an expert on melting points. So what's the melting point of butter?
Thank you. The average melting point of butter is 35.5 degrees Celsius, or 95.9 degrees Fahrenheit. It's lower than the 100 degrees Celsius melting point of water, because this butter is mainly fat, so bonds are weaker. When we take the butter out of the fridge, it is at 3 degrees Celsius. We use the equation Q equals mc delta T. We can calculate the amount of energy in joules required to melt 8 ounces of butter. The mass is 226.8 grams. The specific heat of butter is 1.26 joules per grams, and the change in temperature required is 32.5 degrees Celsius. When we multiply that up, we see that it will require 9,287.5 joules to get the butter to its melting point. Now, of course, we will use the heat of fusion to see how much energy is required to change the state of butter. When multiplied by the mass, we see that it will take 23,264.4 joules to fully change the butter into a liquid. When we add these together, it will take a total of 32,551.9 joules to heat and melt the butter.
Well, you're one smart cookie. But we're not baking cookies. We're making brownies. Well, as this mixture forms, let's get our mixture expert out. For everybody, let's give a round of applause for Miles.
Thank you for having me.
Oh, no problem. So, what can you tell our viewers about mixtures?
Mixtures are very complex creations. Brownies are a mixture that is a similar compound makeup to air, blood, saturated, and sugar and water. Homogeneous mixtures are mixtures that look the same throughout, so you cannot see individual particles or materials.
Well, that sounds interesting, but now for our viewers' sake, how does this relate to brownies?
As you can see, the ingredients will bond and come together to form a delicious mixture that looks the same throughout.
So, that seems good. Well, I don't know about you, but I bet our viewers out there, including myself, would like to get cooking. So thanks for stopping by.
Thank you.
Don't forget that on the way out. Now finally for our last co-host, let's hear it for Lauren.
Boo.
How are you doing, Lauren?
I'm good, Paul. How are you?
I'm good, thanks for asking. So we have you here today to discuss how the oven is transferring the heat to these brownies.
Oh yes. Well, Paul, when we preheated the oven earlier to 350 degrees, radiation occurred to heat the oven. But now that the oven is at 350 degrees, convection is occurring.
Well, I think that's all our viewers needed to know, so thanks for driving here all the way from Alaska to our San Diego studio. So, have a fun trip back. Bye-bye. Well, this is the final product, which is high in fat, carbohydrates, and low in protein. So this makes it a perfect treat for chemistry kids. So that's all we have for you today. Bye.
I really don't understand why